Question 22, we've got a nice triangle here, and it says that we've got our dimensions and we are charged an annual tax for anything that is along the street side. So essentially, what we need to figure out is how much real estate is along this street side. Well, we've got a side angle side triangle, so that means we get to use the law of cosines for this problem. When I set this up, this is a formula that will be provided to you, the law of cosines. You've got the side length across from it, so we'll call that the street squared is equal to both of the side lengths squared, 28 squared plus 46 squared, minus 2 times each of the side lengths again, multiplied by cosine of 80 degrees, squeezing that value on there. I can enter this into my calculator and then take the square root, and that's going to give me the length along the street. The length along the street is about 49.5. But this question's asking me how much tax I have to pay, so we need to multiply this by $25. And when we multiply that by $25, we get about $1,238.11. So A would be the closest value to that. Number 23 is also an inverse problem. They just kind of snuck it into a word problem. This is an inverse of a rational equation, so you're going to switch x and y and solve for y. 250y plus 1 over y. Multiply both sides by the denominator. Xy is equal to 2.5 or $2.50. Y plus $1. Get your y's on one side of the equation. Xy minus 250y equals $1. Factor out the GCF, which is y, since that's what we're solving for, and get y alone. So divide both sides by what's in parentheses, $1 divided by x minus 250. So y, or the inverse of this equation, is most closely represented by choice A. Number 24 is one that you kind of have to think about. A computer rental company charges $50, kind of a base price, to rent the computer for 1 week. Then we're given a chart for all the late fees. RIP Blockbuster. You don't even know what that was, but that was DVDs, not computers. This particular person rents a computer for 1 week and returns it 15 days late. So the rental itself is going to cost the person $50, just kind of a base rate. Then it's 15 days late. So since the first day through the 10th day, we're only being charged a $5 fee for 10 days. So that's $50 the first 10 days it's late. Then that rate bumps up a little bit because these people need their computers back. So day 11 to day 15, you're now being charged $8 for those 5 days, which is $40. So if I were to add these three up, 50 plus 50 plus 40, that person is paying $140 for their computer rental. The last problem from this mock exam deals with right triangle trig. It's a two-part problem. Angie's looking up at the top of a building when she is 100 feet away from that particular building. So here I'll kind of draw a triangle. The distance she is away from that building is 100 feet. And she looks up at an angle of 40 degrees. Then she's going to walk 20 meters closer, or 20 feet rather, and look up at the same part of that building. And we need to figure out, what angle is she looking at now? Well, based on the movie theater example that I talked about when we were learning about angles of elevation and depression, the closer you sit in a movie theater, the further back your head has to go. So we know that this angle needs to be bigger than 40 degrees. So we could eliminate 32 degrees already, kind of using some context clues. So what we're going to do is think about this as two separate triangles. First of all, the outside triangle is the one with the 100 and the 40 degrees. Let's solve for the height of this building. The height of this building is the opposite side of the angle. We also have an adjacent side, so tangent of 40 degrees is equal to h over 100. Multiply both sides by 100. Tangent of 40 degrees is equal to the height of that building. That building's height is approximately 83.91 feet. Now that we know that, we can think about that little orange part of the triangle. So thinking just on that inside part of the triangle, now we know the height. We also know the base. Since the entire length is 100, she walks 20 feet closer. That must mean the base or her distance is 80 feet away from the building. So we can set up another tangent problem. Tangent of, we don't know, question mark, is equal to opposite 83.91 over adjacent 80. In order to solve for the angle, we do inverse tangent or arc tangent. Inverse tangent of 83.91 over 80. After we evaluate that in the calculator in degree mode, gives us 46 degrees. So a little bit bigger than that initial angle, but based on that movie theater example, when you get closer, your head has to go back further or your angle of elevation needs to increase.